We're going to continue our 8D series by looking at D4, root cause. Now, by definition, root cause is an event, condition, or state that, when removed, remediated, or controlled, prevents recurrence of an undesirable behavior. Root cause is the least understood and the most difficult part of 8D. We really need many root cause tools at our disposal. It requires the practitioner to really think, and to get good at root cause analysis, we need to practice, and we need to practice really a lot. Here's a list of root cause tools down the left-hand side here. So we have the is, not tool, fault tree, process map, 5 whys, a multivariate study, failure modes and effects analysis, Pareto charts, fishbone diagrams, interrelationship diagrams, current reality tree, scatter plots, concentration charts, design of experiments or DOE, tree diagram, brainstorming, regression analysis, artificial neural networks, component search. There are others. These are just the ones that I've used, and it's a reasonably complete list of root cause tools. Now, what I've tried to do for each of the tools, I've tried to assess the tool complexity, the time requirement, the ability to find its ability to find root cause, the level of subjectivity involved in the tool, its intuitiveness, how easy is it to use, whether or not it requires a cross-functional team, and the number of factors that can be studied with the tool. And I'm using a low, medium, high type assessment. So, for example, the is, not. The tool complexity, it isn't an easy tool, but it's not overly complex, so I put it here as sort of medium complexity. It is quite a high time requirement, although it does have quite a high ability to find root cause. The level of subjectivity is quite low in this tool. It's not entirely intuitive, so I put this at sort of medium. It does require a cross-functional team, and the number of factors that it can potentially identify is actually pretty good. All right, so I've done that for each of these. And so for this video, what I'm going to look at are 4, and I limit these 4 in my trainings on 8D. However, I do include each of these in the 8D template because then you have access to each one, and you will use those as the situation requires. So let's go into the is, not. Now, we've seen a piece of this before. It's based on the problem definition in D2. It does consist of a series of questions, and it looks at problems from a multitude of views. And so let's cover an example. Just take a moment to tell me what you see here. Try and describe what it is you see. Now, tell me what you see here. And I'm wondering how many people actually realized they were looking at a pencil, a standard pencil, from 2 different views. Well, that's the whole purpose of the is, not. It asks the who, what, where, when, why, and how, and it ensures that the team is seeing the problem from all possible angles. There's 5 steps to is, not. The first one is complete. We did that up in D2, the problem definition. And we pick it up at step 2. What we're going to look for is differences and changes between is and is not by asking the question, what is unique or different or special when we compare the is and the is not? And we're trying to identify or list new information only, and that new information must be true of the is part of the answer given over here in D2. Once we have the differences identified, we say, okay, now that we know that this is different, how could this change have created the problem? So we do know something is different, and is it possible that it's creating the problem that we are investigating? And if and when the answer is yes, we want to list a possible cause for each change here. Okay? Moving then over into step 3, we're going to make an assessment, and we're going to select the plus sign or the minus sign. And we're going to select the plus sign when both the is and the is not is explained by the possible cause. So I'm looking at a possible cause, and I'm saying, does that explain both the is and the is not? And when the answer is yes, we select the plus sign. And when the answer is no, it really only explains one or the other. I'm going to use a minus sign. And we'll do that for each question in the is and the is not, and we'll carry on through this process. Step 4, we're going to sum the plus signs and the minus signs for each possible cause, and the possible causes with the highest number of plus signs will be our root cause or potential root cause. Now, moving over to the 5 whys. So the 5 whys is a problem-solving methodology used to demonstrate a cause and effect relationship, and of course we're looking for root cause, and we want to discover or uncover that root cause. The method is we ask a question why. 5 times is the rule of thumb. Could be more, could be less, but 5 is a good start. So we're going to ask the question why 5 times. And in the hope that the root cause of a problem can be identified. So let's use a little example here. And perhaps the problem I'm having is my car won't start. And so then you might ask, well, why won't your car start? And the answer is, well, it ran out of gasoline. And then you ask, well, why did it run out of gasoline? I forgot to fill it up. Why did you forget to fill up the car? Well, the fuel gauge doesn't work. Why doesn't the fuel gauge work? I forgot to have it repaired. Why did you forget to have the fuel gauge repaired? I didn't write it on the repair list when it broke. And that becomes then our root cause. Now, there's some pitfalls with using the 5 whys. As you can see here, it's a very simple method, but just be careful and be aware that teams may stop at symptoms before they actually get to the root cause itself. Its effectiveness is limited to the collective team knowledge. It doesn't really guide the team to ask the right why question, and different people using 5 whys might come up with different causes for the same problem, so the results are difficult to repeat. So here's what I would say, and my recommendation to teams are: mitigate these pitfalls by grounding the 5 why method in observation, not deduction or logic. Okay, I want you to think about that. So mitigate these by grounding the 5 whys in observation. Go and see the problem and assure yourself that the answer you're giving is what you observe, not so much what you think should be happening. Okay, moving on to the next one, which is the Fishbone Diagram. It's also known as the Cause and Effect Diagram or the Ishikawa Diagram. It's used as a structured brainstorming tool. It helps identify the possible inputs, what we call the X's, that are causing the problem, known as the process Y or the big Y sometimes. The big Y is the process defect that we're trying to focus our efforts on. Generally, we'll begin by labeling the bones on the fish with these: measurement, material, people, environment, methods, and machines. Now, you can use other labels. And hopefully it's going to help us identify a root cause. So let's have a look at the Fishbone Diagram. So here is a cartoon of bones in a fish. Notice that this little graphic is separated by this dashed line here, and to the right of it we have the issue, the big Y or the problem. And then on the left hand side this is all the X's. Okay, so this is the Y and these are the X's. Here are our labels. These are the ones we just saw: measurement, material, people, environment, methods, and machines. And what we're going to do is we're going to begin with, say, people. And the question we ask is, are there people issues that could be causing this problem, the big Y? And if there is, then we list it here. Now, if there's sub-issues, we can put those underneath here. So it's indicated as like a level 1 and a level 2, right? And are there any other people issues? And we might list this here. And are there any other people issues? And we list it here. And then we move over to materials, and we do the same thing. What are the material issues that could be causing the big Y? There may be none, but when there is, you can list them here. And we're going to move all the way around the fishbone. It's not uncommon to have 30, 70, or 100 different issues that could be causing the potential problem. In fact, it's very common to have those, and so we want to use some kind of a screening method. You know, I can't go work on 100 things, but I could go work on maybe 3 or 4 things, you know, a small short list. So how do you get to that small or short list? Well, there's a couple of methods. The first method I'm going to mention here is what we call CN and X. So I'm going to go around and label each of the causes I've identified by using a CN and X. All right. What's CN and X? C are those items that we know must be held constant with, say, a standard operating procedure, for example, okay? And it's required in order to ensure consistency of the output. N are noise variables. These are possible causes that we cannot control or we choose not to control. And then the last one is variables that we need to consider a little bit further, what we call the potential key process input variables. Now I'm going to go back one slide because there's another method I can use as well, and that is the implementation and impact analysis. And so I might, for each one of these, say, all right, if I were able to address this issue, to what extent is implementation of that easy or hard, and what kind of an impact do we think it would have on the big Y itself? Would it have a high impact or a low impact? And we score them 1, 2, 3, and 4, and so I put it here. And I do that for each possible cause listed. I'm going to move all the way around the fishbone diagram, and then I'm going to select, in the first case, the number ones, because they are the easiest to implement and they have the highest impact on eliminating or removing the defect of the big Y. All right? And then I would move on to the number 2 items and the number 3 items. So that's another way to screen down this multitude of issues into a shorter list. Okay, let's move on to the interrelationship diagram. It does help us to distinguish between cause and effect. It's used to understand the relationship between issues around a given problem. It is very good for identifying people or organizational root causes. Very easy to understand and a low time commitment. So let's have a look at the interrelationship diagram. It too is based on the is not problem definition that we saw up in the D2 tab. And I'm going to take each issue and I'm going to put them in perhaps a little box here and put them in a circle of some kind. Okay, so where I start and where I stop is not important. The order here is not important. What is important is I get all of the issues in a circle. All right? And then what I'm going to do is pair up each one. So I'm going to look at issue 1 and issue 2, and I'll ask myself, is there a cause and effect relationship between the two? And if there is a relationship, a cause and effect relationship, I'm going to draw a one-headed arrow that's pointing to the effect. So let's suppose I did identify an issue, a cause and effect relationship, between issue 1 and 2. Then I'm going to move on to the next pair, which is issue 1 and issue 3. And I'm going to ask the same question and draw my arrow if it exists. Then I'll take issue 1 and issue 4, and so on, issue 1 and issue 5. Okay? Once I've done all of those, I'm going to move over to issue 2, and I'm going to start pairing it up with issue 2 and 3, and then issue 2 and 4, and then issue 2 and 5, and so forth. And I'm going to continue to move around this circle, selecting each issue and all of the pairs associated with it until I've got all pairs covered. And then the last thing I'm going to do is I'm going to do a count. So I'm going to look at all of the arrows that are pointing into a given issue and all of the arrows pointing out, and the issue with the most outs are my most likely root cause. So let's go over to Excel and have a look at how these play out. So here we are in Excel, and I'm down at the D41 tab, and this is the list of root cause tools that we looked at. So we'll just go ahead and dive right into the is not. And the first thing I want to point out is this part of the is not comes from the D2 tab. All of the information entered there will show up here, and so we just have it here as a reference. So we're going to start over here, and we're going to start looking at differences. And so the question I'm trying to answer is, what is the difference between customer A and B, who is experiencing the problem, and customer C, who is not experiencing the problem? And the difference that I've identified here is that customer A and B are longtime customers. Customer C is not. They're a new customer. Okay, if that's true, What kind of a change could have taken place that might have differentiated customer A, B versus C? Well, customer C was added in the last month. What's the time frame? About a month ago. And therefore, what is the possible cause that's differentiating customer A and B versus customer C? Maybe it's the new customer onboarding process. All right. And I will go down then to the next set of questions, and I'll make my way across here and answer this and identify maybe a possible cause number 2 and a possible cause number 3 and so forth. Okay. Now I'm just going to scroll over to the right here. Once you've identified a possible cause, it's going to translate itself over here automatically. You don't have to worry about rekeying that in. And I'm going to ask the question, does new customer onboarding process explain why customer A and B are experiencing the problem and customer C are not? And the answer might be, well, yes, indeed, it does. Or the answer might be, well, not really. It really only explains the is part of it. Let's just assume for the example, though, that it does explain. And I'm going to do the same for this next set of questions. And I'm going to score it. All right? And as I complete this matrix of scoring, I just scroll down, and it's going to sum up then all of the pluses for a given cause. Because remember, each of these columns now represent a possible cause. So there's possible cause 1, cause 2, cause 3. Right? And it's going to sum up all of the pluses, all of the minuses, and then this little table down below will present those results to you in descending order. And so the most likely root cause is given here as new customer onboarding process. Why? Because it has the most pluses of all of the possible causes we looked at. The second most likely root cause is going to be this number 2. Why? Because it has the next highest number of plus signs. And so this is very good at, because as you can tell, it's quite a comprehensive review, and it's actually very good at identifying root cause. All right, I'm just going to scroll back here. I'll scroll back, and we'll go back to the root cause list. Okay, so that is the is not. Now, the next one down are the 5 whys. So we begin here by describing the failure. In the example we were using, the car won't start. And I might say, well, why did this occur? Why did the car not start? Well, it ran out of gasoline. Now, right here, I want you to answer the question, do I need to confirm this? And if the answer is yes, then I will go ahead and record that here, how this answer was confirmed. And if the answer is no, then I make my way down to the next why, which is, why did it run out of gasoline? Well, I forgot to fill it up. I'll just scroll down here. And for the sake of this video, we'll assume that they're all no. So I forgot to fill it up. That's because the fuel gauge wasn't working. The fuel gauge wasn't working because I forgot to have it repaired. And I forgot to have it repaired because I didn't put it on the list. Now, there is one little technique you can use to assure yourself that successive statements were logical. And we do that by using the therefore technique. So I'm going to start now at the bottom, not at the top, but at the bottom. And I'm going to see if there's a logical connection between this statement and the one adjacent to it. So I didn't put the fuel gauge on the repair list when it broke. Therefore, I forgot to have it repaired. So if those two statements logically connect, then I'm pretty well assured that one is the result of another. Okay? And then moving up to this one, I say I forgot to have the fuel gauge repaired. Therefore, it doesn't work. The fuel gauge doesn't work. Therefore, I forgot to fill the car up with gasoline. I forgot to fill the car up with gasoline. Therefore, I ran out of gasoline. And I ran out of gasoline, therefore the car doesn't start. And so again, if you can make that logical connection, you can be pretty well assured that what you've identified down here as root cause is indeed root cause. You'll notice there's instructions over here on the side that guide you each step of the way. Alright? So let's go back now to our root cause list, and we'll go to the next one, which is the fishbone. So as we saw on the slide a little earlier, we're going to describe what our problem is here. This is our big Y, and then using the labels of material, people, measurement, we're going to just identify the potential cause right here. And then using a CN and X or a implementation impact analysis, we're going to score each one. And again, I'm just looking for a short list, and particularly with the fishbone, when you've got a lot of potential X's, I'm trying to narrow it down to 1 or 2 or 3 or some very short list of possible causes that I can then go do some further investigation on. Okay, let's go back to our list, and then the last one is the interrelationship diagram. So here are each of my issues. In this example, I'm going to use the use the problem. We don't use a structured methodology to solve difficult problems where I work. Why is that? And so, well, maybe one of the issues is we don't think it will help us. Maybe we don't know any methods. Perhaps a structured methodology is just too slow. Maybe we're afraid to ask questions because we're educated and smart people. Maybe we want to avoid embarrassment. So the order of these is not important. What is important is they're in sort of a circle. And what I'm going to do is then take each of these now, pair them up, and ask the question, is one a cause and one an effect? So I don't think it will help, and I don't know any methods. And in this case, we're going to say, well, really, this is the cause, and that might be the effect, right? So I don't think it'll help. Therefore, I'm not going to spend any time learning any methods, okay? And I draw my one-headed arrow pointing away from the cause and into the effect, right? And let's just say that's 1 point, okay? I'm going to take the next pair, which is this one and this one. I don't think it will help, and the methodology is too slow. And if there is if there is no cause and effect relationship, then there will be no arrow. If I'm not sure if there's a cause-effect relationship, or I don't believe it's strong, then I can use sort of a dashed line, and we'll give that maybe a half point. Then I'm going to look at the next pair, which is this one and this one, and apparently there's no cause and effect relationship, and none between this. Okay? So I've exhausted all pairs for this issue. I'm going to now go over and start here and pair it up with this one, and then this one, and then this one. Okay, and make my way around, and then I'm going to go here and pair it up with this one, and then this one. And pretty soon you'll run out of unique pairs. Once I'm done with that, I'm going to do a count, and I'm going to ask myself, how many arrows are pointing out of this box? Well, in this case, there's 1.5 if each is worth a point. And how many are pointing into the box? We don't have any arrows pointing into the box. All right, in this case, how many are pointing in? Well, 3 are pointing in. How many are pointing out? None. And the idea is, when I've done that for each issue, I want to count or identify that issue or box with the highest number of outs, because that's my possible or potential root cause. Okay, so in this case, my potential root causes are the highest number of outs is this one, so I want to avoid embarrassment. So that's the root cause. I want to avoid embarrassment. And the second most likely root cause is the one where we've got 1.5, which is I don't think it will help. So it's a very effective, very easy tool, and has been used with great success. So that's the 4 root cause tools that we are going to cover in this video. I would encourage you, though, to become familiar with really all of these root cause tools. The root cause analyst must have many, many tools available to them, and this is a great place to start. Each one of them has instructions like the tools we reviewed, and again, I would encourage you to spend some time, apply them, get to know their limitations, and you too will be very good at root cause analysis. Okay, that concludes this video and the D4 part of the 8D process. You can go out to sixsigma.org. The website has a lot of information out there, and tools and templates, many of which are free. And I would also encourage you to consider purchasing the 8 Disciplines Methodology of Problem Solving, where we look at each of these tools in incredible depth. And it's a great resource to help you become good at root cause analysis and 8 disciplines. See you next time.